Hello everyone, my name is Bodo Bakar Muhammad. I recently upgraded my AWS 3-tier project by adding containerized deployment, observability, monitoring, and alerting. So previously, the application were deployed as static artifact. So this upgraded version use Docker image stored in Amazon Elastic Container Registry and deployed through GitHub Actions. So this GitHub Actions workflow automate the deployment of my Dockerized application. Whenever I push change to the configured branch, so it built a new Docker image and push them to Amazon Elastic Container Registry and refresh the other scaling group so the EC2 the EC2 instance deploy the latest container. So on the top of that, as you can see on this diagram, this is the observability stack. So it has Prometheus and Grafana. Basically, they are basically they track Prometheus and Grafana. They track and display the performance of the EC2 instance, and Prometheus is like the collector. It gathers raw numbers from the EC2 instance, like CPU usage and disk space, memory, and store them. Whereas Grafana is the display, so it takes those raw numbers from Prometheus and turns them into visual chart or graph for analysis. The alert manager is handle the security and performance warning for this monitoring system. Yeah, whereas the block box exporter basically is probe the endpoint over protocols like HTTP or HTTPS, and then monitor, their availability and their response time. So in addition to Prometheus, I also use Amazon CloudWatch to monitor AWS managed services. So basically, CloudWatch is responsible, for collecting native AWS metrics such as application load balancer metrics, EC2 metrics, and other services metric. And then, especially in this project, I configured a CloudWatch alarm to monitor, the application load balancer uh, metrics error. So basically what it does is that if the numbers of 5xx response exceed the configured threshold, and then CloudWatch change to the alarm state, and then it's going to send an email notification through Amazon SNS. Basically, this complement the Prometheus monitoring stack, while Prometheus focus on application health, infrastructure metrics such as CPU, disk usage, and HTTP endpoint availability, and CloudWatch provide the visibility into AWS native resources that are managed by AWS. So combining both those monitoring stacks uh, provide a more complete monitoring solution. So this upgraded version of my project focused mainly on observability and monitoring stacks. So let me walk you quickly to the application infrastructure code. So basically, this is the deploy app YAML file. This is the pipeline. So as you can see, the branch is main, and this is the path where it has, the app 1 and app 2. So those are the app 1 and app 2. So basically it contains the app.js file, Docker file, index, same for app 2. And then, this is the region, and this is the account to identify. This is the app 1 Elastic Container repository. This is for app 2, the auto scaling group name. So basically this is the deploy app YAML file, and then this is the Elastic Container registry repository. Yes, this is the ECR repository for app 1 and app 2. And this is the observability stacks. Those are the upgraded version. So this is the alert rules. This is the alert manager YAML file. This is the main. So this is the user data, and this is Prometheus YAML file. So I'm going to quickly do a live demo. So I'm gonna update the deploy app YAML file, and then the pipeline will run automatically, to do all those jobs. It's going to basically is going to push the code and then build the Docker image and push this image to Amazon Elastic Container Registry, and it trigger the auto scaling group instance refresh, and then deploy the latest image. So we're gonna do that now. So I quickly made a change. I just added a new branch. This is the Docker, the branch that where I developed the upgraded version. So I added it. So now I'm gonna push it to GitHub repository. So we're gonna run this git app, and then this is the workflow that we're gonna need to add it. So let's get the commit -n update deploy start. Okay, so let's just click push. So now the pipeline will run automatically to do the job. So let's go to actions. As you can see, the pipeline is running automatically. Basically, it's gonna do all those jobs, build the Docker image, and then push it to Amazon Elastic Container Registry, and then it's gonna trigger the instance refresh to use the latest image. So all those jobs is done in 27 seconds. So now that we run the pipeline, let's quickly see what we built, what the deployment inside the AWS console. So let's go to Elastic Container Registry. As you can see, it successfully, built the image and deploy them. So So those for app 1 and app 2. As you can see, this is the latest image that recently deployed. So this is successful. So after successfully testing the pipeline, so now it's time to test the observability stack. So let's go to the AWS console. So basically, after running the pipeline, so the all EC2 instance were terminated, and then the auto scaling, and then with the launch template, they created a new instance. So those are the running instance. So I'm gonna, take one instance and then run the test. So before that, I quickly want to show you the application itself. So this is app 1. As you can see, it's functional, has a custom domain, with HTTPS connection. So basically, this is like a, sample, application. And this is app 2. Let's switch to app 2. Okay. So this is the app 2. So they're all working fine. So now let's go and test the observability stack. And also I have Prometheus open. So this is Prometheus. Basically, this is like it has collected all the metrics. As you can see, this is the black box explorer, the endpoint for app 1 and app 2, the ones that I show you. It shows the state is up, means like they're all running successful. When it's down, so it's going to show as down on over here. And then this is the instance. So I have 4 instances running, like two up 1, up 2, two, like up 1, up 2, up 2, and then up 1, up 1, like 4 instances running. And this is, as you can see, this is the private IP. So they're all running. So I'm going to test one of those instances. And this is the alert manager, like user interface. Wherever like the CPU utilization of the one of the instance is maybe is high, we're gonna be receiving alert here. And this is the Grafana user interface. That basically that's gonna show us, you see the CPU and the memory and all the instance monitoring stacks. So from here we can monitor our instance uh, without issue. And we can switch to wherever instance we want, using the private IP address. So now we're gonna take this instance specifically to monitor. As you can see, as of now, the CPU utilization is 0.3%. So, and it's n 138. So let's go to Prometheus as well. We can see that. So 138. So now everything seems good. And let's see the alert. So there is no alert as of now. So everything is running fine. So once, especially the CPU like utilization is above 80% for 1 minute, now we're gonna be receiving is going to change CPU high, and then we'll receive alert. So those are different alert that we're gonna receive. The instance is down. If one of those 3 instances, for example, one of those is down, also we're gonna receive alert instance down. So hide disk usage. So those are the alert that we are going to receive. So now I'm going to focus on CPU test. So this is the instance. As you can see, I'm going to connect to this instance using AWS console. So I successfully connected to the instance. Now I'm going to run the command to increase the CPU utilization, and we're going to be receiving the alert live. So now if I run this command multiple times, or the CPU will be increasing, and then later we will receive alerts. So now let's switch to Grafana and see. So now we are at 0.44%. So let's see how it's going to be increasing. So as you can see, 2.8% now. So still not receive alert. So we are at 12.8%. So everything seems good now. So we don't have any sign. So as you can see now, it's showing us pending state, which means like the CPU is getting high little by little. So we're gonna be receiving alerts soon. So let's see alert manager. We still didn't have any alert yet. So as you can see, is showing us exactly the instance that we are monitoring. So you can see this instance, it enter with 138, the same instance that we are monitoring right here. As you can see, 138. So once we receive the alert, also it's going to show us the instance private IP exactly. So we know exactly. As you can see now, we have this instance. You see the alert is received live 138, and alert name CPU usage high, and severity is warning. This is just warning. So now once we go to Prometheus again, let's refresh, and we can see, so it's red now. All the other alert are green. So now at the same time we're going to be receiving email about this instance, this specific instance. So as you can see, I have my email open here. So I received the same alert through via email, the same instance, CPU utilization high, so this is like basically successfully monitor the CPU utilization. So now we are at 72%. We can also go to the instance and check which instance is running, consuming all those CPU using the top command. So we can see exactly monitor the instance running using the CPU utilization. So as you can see, this is the CPU percentage. This instance is specifically using 70%. You can see like it's live. So we can monitor using this Linux command exactly, and we can kill the instance if we don't need it. So now that I tested successfully, I'm going to kill the instance. So now I terminated the test. As we're gonna see decrease of the same instance. So now we are at above 80%. Is gonna decrease, and then we will proceed with the next test. As you can see, it's high, and then now I killed the instance. It's showing exactly the it, once I stopped it, so it is gone now. It disappeared, and we still have the alert, but as you can see, also it disappeared, and then the instance is gonna be decreasing. We're still at 80, above 80, but it's gonna decrease. As you can see, it's decreasing a little bit. Now we are at 79%, so it's gonna decrease. So now we're gonna proceed with the next test. So I'm going to AWS console to stop, like manually stop one instance, one of those uh, instance, and then we're gonna see the instance down alert. So let's go to this specific instance that we run the test. This instance 138, the private IP end with 138, which is this one, and then I'm going to terminate the instance. Just terminate, and then let's see how. Let's check Prometheus. It's gonna show us instances down. Not yet. As you can see, so it shows us exactly, the instance is down, so the state is down, all the remaining are up. So this is the instance end with 138. So, and then let's see the alert. You can see also it's still fearing, you know the pending status, so we're gonna be receiving the alert soon as well. So once I terminated the instance, you see before that it has all the numbers, so now there is no data because the instance is gone. So let's check the alert manager and see. We still didn't receive alert yet, but we're gonna be receiving soon. So for this specific use case, probably I did not receive alert because this is because of the self-healing instance. Once I remove delete the instance manually, so the auto scaling, and then with the launch template, they initiated the replacement to replace the instance that I deleted manually. Automatically, a new instance is created to replace the one that I deleted. That's why I did not receive the alert. So as you can see now, this instance is initialized. This is the power of self-healing application. Even if you delete the application manually, the auto scaling, and then with the launch template, they're gonna initialize a new instance to replace the one that deleted manually. So at the same time, if I want, I can still do some tests on high disk usage, and the availability alert is going to show us the apps endpoint, whether it's down or work functioning. So with that being said, so I'm going to stop here. So basically, this upgraded version of this project, uh, transform from a traditional three-tier application into a more production-oriented, platform with containerized deployment, uh, observability, automated monitoring, alerting, and self-healing infrastructure, as we just as I just demonstrated. So thank you for watching. Any feedback is welcome. I'm currently seeking a junior cloud engineer or DevOps opportunity.